Now let us see some important remarks in the first chapter. Okay. Now the first one is, what is the importance of what is the importance of defining the order of convergence, or rate of convergence. Order of convergence, rate of convergence, both are same. Convergence of a method. The answer is, to explain clearly this concept, suppose we are using Newton-Raphson method. Let us assume, suppose we are using Newton-Raphson method for computing a root of the equation f of x equal to 0. Okay, you know what is the formula? Xn plus 1 equal to xn minus f of xn by f dash xn. Let us assume that uh, at a particular stage of iteration, let us assume that at a particular stage of iteration, the error means exact minus approximation, the error in magnitude only, don't consider negative sign or positive sign, only magnitude value, the error in magnitude in computing the root, is 10 power minus 1, that is 0.01. Error is what? Error is what? 0.01. That means exact root minus approximate root is equal to, the difference is 0.01. Okay, next one, what we observe, what is the error formula, what is the error equation? Error equation in NRM, what is error equation in NRM is what? Epsilon k plus 1 is equal to what we have, c into epsilon k square, second order convergence. I think you remember this, second order convergence. That is, in the next iteration, in the first iteration, what is the error? 0.01. Now in the next iteration, what error may be? In the next iteration, the error behave like c into epsilon k whole square, right? That is c into 10 power minus 2, isn't it? C into 10 power minus 2, that means c into 0.01, c into 0.01. Okay, that is we may possibly get an accuracy, how much accuracy? 2 decimal accuracy, an accuracy of 2 decimal places, accuracy of 2 decimal places, 2 decimal places. Because of the quadratic convergence of the method, we are getting this error, right? However, this depends on what? C. It depends on what? C, right? Convergence, the rate of convergence of bisection method, regular falsy method is is 1, and secant method, just I'm explaining some method. Secant method is 1.618. Therefore, by using by using NRM having rate of convergence, having rate of convergence 2, we get we get accurate result, we get accurate result within less number of iterations, within less with less number of with less number of iterations. That is the benefit of rate of convergence, with less number of iterations. Okay, this is the idea of rate of why we have to study rate of convergence means, if any method is having more rate of convergence means within less number of iterations we will get more accurate result. Okay, and second point, what is called computational cost. Computational cost, what is mean by computational cost? Computational cost means it is the number of it is the number of function evaluations, number of function evaluations at each iteration, at each iteration of the method, of the method. Let me explain this. Number of function evaluations, number of function evaluation is called computational cost of the method. For example, in bisection method, what is in bisection method, what we have to do in bisection method, we have to bisect the interval, we have to bisect the interval at each iteration, at each iteration, right? This is the process. After bisecting this one, then we have to find f of x naught, f of x naught, or next second iteration f of x1 or f of x2, like that. That is one function evaluation, one function evaluation is required in bisection method. Therefore computational cost of bisection method is 1. Bisection method is 1. Okay, in bisection method, at each after finding root we have to evaluate f of x naught. After getting x1 we have to evaluate f of x1. After getting x2 we have to evaluate f of x2. That means at each iteration only one function, that is f, is evaluated at the particular point. F is evaluated at the particular point. So one function evaluation is required in bisection method. Okay, now in secant method, in secant or regular falsy method, in secant or regular falsy method. Okay, what is the formula of secant method or regular falsy method? Xk plus 1 equal to xk minus 1 f of xk minus xk into f of xk minus 1 by f of xk minus f of xk minus 1. Right, this is the formula. Then find f of xk plus 1, right? That is at each iteration we have to find what values we have to find. F of xk, f of xk minus 1, f of xk minus 1 firstly, then find f of xk minus xk plus 1. That is one function is evaluated, only one function f is evaluated at xk minus 1. Therefore computational cost of secant method, secant or regular falsy method is what? 1 function evaluation is enough. One function is evaluated. Now coming to Coming to now Newton-Raphson method. Newton-Raphson. Coming to Newton-Raphson method. What is the formula? Xk plus 1 is equal to xk minus f of xk by f dash xk. That is at each iteration we require what values? We require f of xk and f dash xk. Now there is another function f dash. That means what? Therefore two function evaluations that is f and f dash are required at each iteration. Therefore computational cost of Newton-Raphson method is 2. Computational cost of Newton-Raphson method is 2. Okay. Now similarly you can define what is the next method? Muller method is there and Chebyshev method is there, right? Muller method and Chebyshev method. In Chebyshev method, what are required? Let us see Chebyshev method. In Chebyshev method, what is the formula of Chebyshev method? Xk plus 1 is equal to xk minus f of xk by f dash xk minus 1 by 2 f of xk whole square by f dash of xk whole cube, isn't it, into f triple derivative of xk. Therefore how many functions? Three function evaluations are required. What are the three functions? F dash, f triple dash. Okay, f dash and f triple dash. Three function evaluations are required in Chebyshev method. CM means Chebyshev method. Therefore computational cost of Chebyshev method is 3. Okay. Similarly you can define Muller's method also. I will stop this one here and let us see third point. When does Newton-Raphson method fails? When does Newton-Raphson method fail? This is the question. Okay, and the answer is, what is the Newton-Raphson method formula? Xk plus 1 equal to xk minus f of xk by f dash xk, right? To find x1 we need x naught, which is initial approximation, correct? Which is initial approximation. How to choose this initial approximation? That is our choice. So the initial approximation is made by our choice, Therefore the method may fail when initial approximation is far away from the exact root. That means if exact root is 2, for example, and we are selecting x naught as some 0.1 is very far to 2, okay, then method may fail. That means it may not converge to that one if I choose very far root. And one more point is what? This is one point, the method fails. This is first point. And when method fails? NRM fails when f dash of x equal to 0 at any root. right? If this denominator is 0, then f dash x 0 means there is no formula does not exist. Formula does not exist at any root. These two are the conditions for the failure of Newton-Raphson method. Failure of Newton-Raphson method. And you know what is the criteria to stop the difference between two successive approximations is very less than epsilon. Okay, that is one point. And another one is, let me tell one more important, these are all CSR topics. Yeah, one more is there, efficiency of a method. The next slide is efficiency efficiency of a method. Which method is efficient? See, when order of convergence is more, the method gives good results within less number of iterations. Okay, but it is not efficient, it may not be efficient method. Let us see the efficiency index. The efficiency index is the number of an iterative method is defined by the equation E star. This is the notation for efficiency index, p to the power of 1 by n. It is p to the power of 1 by n, where what is p? P is order or rate of convergence. And what is n? It is not number of iterations, it is number of function evaluations at each iteration. This is efficiency index. Now using this, let us see what is the efficiency index. I will construct one table. This is method, and n means number of function evaluations, p stands for rate of convergence, and e star stands for p to the power of 1 by n. Okay, let us see now what is the first method. Bisection method. How many function evaluations? Only one. What is the rate of convergence? 1. So this is what? 1. Next, second method is what? Secant method also number of function evaluations 1. And what is this? 1.618. One can take approximately 1.62. So p to the power of 1.62 power 1 by 1. This is 1.62 is efficiency index. And third one, regular falsy method. In regular falsy method also number of function evaluations 1. What is the rate of convergence? 1. So this is 1. Efficiency index also 1. And NRM, Newton-Raphson method, number of function evaluations 2. Right? And what is the order of convergence? It is also 2. So what is E star? P to the power of 1 by n. 2 power 1 by 2. 2 power 1 by 2. Root 2. Root 2 means what? 1.41. Root 2 means what? 1.41. And the fifth one, let me write the next slide. The fifth one, what is this? This method, number of function evaluations p, efficiency index p to the power of 1 by n. Right? What is the next method? Bisection is over, secant is over, NRM. So fifth method is what? Chebyshev method. Let us see. Chebyshev method. What is Chebyshev method? Number of function evaluations 3. What is the rate of convergence? Also 3. So this is 3 power 1 by 3. 3 power 1 by 3. This is 1.44. 1.44. And sixth one, Muller method. How many function evaluations? Only one function evaluation. And what is the rate of convergence? 1.84. So this is 1.84 power 1 by 1, 1.84, right? So clearly I am writing once again here. Therefore efficiency index E star is given by for bisection method it is, for bisection method it is 1. For secant method, it is 1.62. For regular Falsey method it is 1. For Newton-Raphson method it is 1.41. Next one, Chebyshev method it is 1.44, and Muller method it is what, 1.84. So which method is most efficient? This one. So more efficient method is 1.84, that is Muller method. After that, Muller method is first. After it, what is the next highest one? 1.62, secant method. Next after it, secant method is efficient. So convergence is different from efficiency of the method. Now students, unit 2, system of linear algebraic equations. System of linear algebraic equations. This is your unit 2 topic heading. Okay, in this one the basic information, the first information, what is system of linear algebraic equations? Generally consider a system of n algebraic equations, n algebraic equations with n unknowns, n equations and n unknowns. How to write this one? First equation, a11x1 plus a12x2 plus and so on a1nxn equal to b1. First equation. Second equation, start with a21x1, a22x2 and so on a2nxn equal to b2 and so on. And the last nth equation, an1x1, an2x2 and so on annxn equal to bn. This is system of equations 1. Algebraic equation means in terms of variable. So, okay, why we have written a11, a12, a1n, a1n? Because this system in matrix form can be written as, in matrix form, what is this? Can be written as ax equal to b, a into x equal to, this is x, a into x equal to b, where a means n by n matrix. How to write this n by n matrix? What is the first row element, first row, first column, first row, second column, first row, nth column. So these are this quotient, a11 this position, a12 this position, a1n. So first row means these are the x1, x2, xn quotients are first row elements. Second row, a21, a22 and so on a2n. And similarly nth row, an1, an2, ann. Okay, this is called coefficient matrix. And what is x? X stands for solution vector. What are the unknowns here? x1, x2 and so on xn. This is n rows and 1 column is solution vector. Vector means not dimension and magnitude. Vector means having 1 row or 1 column is called vector. Any matrix with one row or one column, only one single row or single column is called a vector. And what is B? B stands for right hand side elements, B1, B2 and so on, Bn. This is also RHS vector. This is called RHS vector. This is general representation of n algebraic equations with n unknowns. Okay. Now, so this matrix can be written as simply one can write this is Aij. Aij, what is the order of the matrix? N by n. Aij means what? I is the index for the row, j is the index for the column. Aij means what? Ith row, jth column element. Aij stands for what? Aij stands for what? Ith row, jth column value. Ith row or and jth column value. Okay. Now some notations, let us see. Notations in this second unit. Notations. Capital A stands for square matrix. A stands for square matrix of order n. N by n matrix. Square matrix of order n. Already I told you what is Aij. Element in the or value. Element in the ith row, jth column. Ith row, jth column of matrix A. Ith row, jth column of matrix A. Next one, A inverse. That is inverse of matrix. A inverse stands for inverse of matrix A. And A transpose. You know all this, but let me tell you. Transpose of A. Transpose of matrix A. And next one, Mij. Mij stands for minor of Aij. Aij in capital A. I think you know this. Minor of means what? Delete ith row and jth column and then value of remaining matrix determinant. Value of remaining matrix determinant. Right? This is called minor. Delete ith row and jth column and then find the remaining whatever the matrix left over, that's determinant. Next one, capital Aij. Capital Aij stands for cofactor matrix. These are all intermediate. Cofactor of Aij in A. That means this whatever the determinant is there, it is multiplied by small aij. And 0 stands for null matrix. 0 stands for null matrix. Next one, capital I stands for unit matrix. I stands for unit matrix of order n. Unit matrix also called as identity matrix. Unit matrix also called as identity matrix. Okay. Now D stands for diagonal matrix. D stands for diagonal matrix. Diagonal matrix means what? Only diagonal elements are there. Diagonal positions are there and remaining all other positions are zeros. Remaining all other positions are zeros. This is diagonal matrix. Next one, lower triangular matrix. Lower triangular matrix means what? The matrix, okay, this is principal diagonal position, and below the diagonal entries are there, and above the diagonal entries are 0. This is diagonal position, above the diagonal entries are zeros, below the diagonals entries are not zeros. That is called lower triangular matrix. And U, upper triangular matrix. Upper triangular matrix. What is upper triangular matrix? Here, upper triangular matrix means the diagonal positions are there, and above the diagonal elements are non-vanishing, and below the diagonal elements are zeros. Below this diagonal elements are zeros. This is upper triangular matrix. And next is P stands for permutation matrix. I will explain this. Permutation matrix. P stands for permutation matrix. I will give definition later on. Next one, this norm, all this Next one, uh, these are the notations, and you write this. This is norm of a matrix. This is norm of a matrix, and this is X. This is capital X. Norm of a vector. Norm of a vector X. Norm of a vector X. These are the notations. Now, some definitions. Definitions. A real matrix. A real matrix. Capital A is said to be. Capital A is said to be. First one, non-singular. Non-singular. If non-singular matrix means determinant A not equal to 0. Second one, symmetric matrix. Symmetric matrix if A equal to A transpose. You know all this, but let me recollect. And a skew symmetric matrix. Skew symmetric matrix if A equal to minus A transpose, right? Orthogonal matrix. Orthogonal matrix. Orthogonal matrix means what? If A inverse is equal to A transpose, that is nothing but A into A transpose equal to I. A into A transpose equal to I. And next one, fifth one, unit matrix. Unit matrix. What is meant by unit matrix? Nothing but identity matrix. Unit matrix is nothing but identity matrix. What is the structure of identity matrix? This diagonal positions are ones and the remaining values are zeros. Then mathematically, how we can represent Aij? These are entries A11, A12, A13, A21, 22, 23, like that. In matrix positions are there. Aij position is equal to 0 for I not equal to j, and is equal to 1 for I equal to j, correct? This is mathematical representation. Okay, next one, sixth one, lower triangular matrix. Lower triangular matrix. What is the definition mathematically? I told you lower triangular matrix means below the diagonal elements are non-zero, above the diagonal zeros. If Aij equal to 0, what is that? Lower triangular means when j is greater than I. J is greater than I. For this I am giving example. This is 1 position, this is 2 position, this is 3 position, right? Lower triangular means these positions are there, 2 1 3 2, and above the diagonal, this is diagonal, above the diagonal the values are zeros. So what is this one? See, this is what is this position? 0 position, A12. This is 1 3 position. This is what 2 3 position. In all these 0 positions, what is the j value? J value is greater than I. J value is greater than I. Simple definition, right? Similarly, upper triangular matrix. Upper triangular matrix. Upper triangular means what? Same. Aij is equal to 0 for I greater than j. For this again same logic I am using. A11, A22 diagonal elements. Upper triangular means these are not zeros. 1 2 is there, 1 3 is there, 2 3 is there. This 2 1 0, 2 1, 2 1 means 2 1. So I greater than j. 3 1 0, right? 3 2 0. So when I greater than j in Aij equal to 0, then matrix is called upper triangular matrix. Next one, eighth one, tri-diagonal matrix. Tri-diagonal. Upper triangular matrix, lower triangular matrix. Now tridiagonal matrix. When a matrix is said to be tridiagonal means aij value is 0 for the difference between I minus j is greater than 1. I minus j greater than 1. For example, I am giving, what is this one? A11 will be there. What is I value 1, j value 1? So 1 minus 1, 0. 0 is not greater than 1. Therefore a11 will be there. Coming to this value a12. A12 means what? What is the I value 1, j value 2? So 1 minus 2. 1 minus 2 means minus 1. 1. 1 greater than 1. 1 greater than 1. Is it true? No. So it is not 0. Coming to this a13. 13 means what? 1 minus 3. 2. 2 is greater than 1. Then what is aij value? 0. So this value 0. This value 0. Right? Coming to this a21. What is the difference between 2 and 1? 1. 1 is greater than 1, false. So not 0. 2 2 also not 0. 2 3 not 0. Coming to 3 1. 3 1 difference, what is 3 1? 2. 2 greater than 1. So this value becomes 0. This value becomes 0. Next one, this is what? 3 2 difference is 1. 3 3 difference is 3. So this is one diagonal. This is principal diagonal, above diagonal, below diagonal. 3 diagonals are there. Tri-diagonal matrix. Tri-diagonal matrix. Is that clear? Okay. Next one, eighth one is over. Next one, strictly tridiagonal. After tridiagonal, ninth one, diagonal dominant. Diagonal dominant. This is important. A matrix A is said to be diagonal dominant if modulus of aii means what? A11, A22, A33 means diagonal position. This is modulus of aii is always greater than or equal to summation modulus of aij j. Now diagonal dominant. Previous slide is suddenly vanished. Diagonal dominant. What is diagonal dominant? Diagonal dominant, a matrix A is said to be diagonal dominant if modulus of aii diagonal position is always greater than or equal to summation j equals to 1 to n and I equals to 1 to n but I not equal to j. Modulus of aij for all I equal to 1 to n. Let me explain this. What is this question here? Problem is, let me consider some 4 by 4 matrix. 4 by 4 matrix, and these are the diagonal positions. This is a11, right? Here a11 value is greater than or equal to aij in the corresponding row. These values, that means what? A12 plus a13 plus a14. Okay, this mod, for every term mod. Similarly, in the second row, this is 2 2, a22 position. This modulus of a22 in second row, it must be greater than or equal to this position, sum of these positions, modulus of a21 plus modulus of a23 plus modulus of a24. Similarly, this one, what is this position? 3 3 position. In third row, a33 must be greater than or equal to a33 must be greater than or equal to modulus of a31, this one plus this one plus this one, modulus of a32 plus modulus of a34, and in the final row this is a44 position. So a44 value is must be greater than or equal to a41 plus a42 plus modulus of a43. It's a simple explanation of diagonal dominance. If mod aii is strictly greater than summation of mod aij, strictly greater than j equal to 1 to n, I not equal to j, then capital A is said to be strictly diagonal dominant. Strictly diagonal dominant. Okay, this is the definition.